Awfer tech stack, and then the Awfer front end, and then how did we couple the design with our design with Kivy, then the walls that we hit, and at the end we're gonna see where we are. Okay, there are gonna be some demos, hopefully no bugs today, and that's all. So, well, let me just try to explain to you quickly what is Awfer. It's like there is no scheme to talk about this, and there is no diagram to explain to you what Awfer is really. So we are a system or an architecture, or let's say a product that is not dependent on any third-party APIs. So except for Twilio and Stripe, Twilio, there is a fix for Twilio. Maybe you could install our own SIMs, but that is like an overkill. But we're dependent on just the Stripe for payments. And except that, we're just fueling with our microservices in-house from scratch, starting from the lowest level, and we operate our system very close to the let's say the operating system, which is Linux. So our whole system runs on Ubuntu. It's just an instance on GCP, and maybe a few more if we reach like a certain threshold of users, and all that has been planned. So this is what we truly are. We are a product that will offer prices that are very, very competitive. And at the end, we will showcase like the difference between us and our top competitor if we ever hit the market. We're going to open in Bristol very soon, so hopefully we're going to finish the Android version. And now let's just get to what makes us special. So start with the Awfer stack. So Awfer technology stack rely on custom built services and communication protocols very close to system level. So if I were to give you a scheme or something, this is what I would give you. So these are the Kivy applications that we have. We have three set of applications. We have the customer application, and we have the driver's application, and we have the control board. All those go through our own designed architecture, which are the rate limiters, spot notification, and the log. And all those are super fast, are super reliable, and they do not break. So we designed this system so it does not break. And at the end of the line, we have a config that the microservices read from. So our design is very simple. It takes very little notions. So we didn't try to like play with tools and that. So we created our own tools, we created our own testing systems, we create everything from scratch. This is the most interesting thing about this project. And if we get to how we're running this, so we're running this services as system D services. There is clear separation for each service. For example, there is the Awfer customer broadcaster, there is the customer login, the rate limiter subscription, until you get to the operators and the drivers, and each has its own like separate microservice, and each client is a separate thread. So there is a clear isolation of everything between every service and between every client. So this is pretty much sophisticated at this moment, and we did like a benchmarking of 110 requests per second, and it has been tested writing into SQLite databases. And coming to the front end and coming to Kivy, let's say, we're gonna say that Awfer uses three apps like I have explained. So we use two for the users, drivers, and customers, and a control board used by an operator. The Kivy framework played a major role in making this product and idea feasible. So if I go back to this project and how did I start this? So it was just like a feasibility test. Could Kivy actually be able to to power this idea. Because coming from a background where I know only Python, I don't know Java, I don't know JavaScript, I have a basic understanding of those. Could I make it work with just like Python? And yes, I could. So we actually reached the point where we could contact the driver and initiate everything. So and even tested the payment, how we could include that into our system, and all that. So Kivy actually could do that easily without any problem. So this is our product. So we do have, for example, this is the customer. This is the customer. This is the customer application. This is the driver's application. The driver could control his documents and could actually add a card, delete a card, select what card to be active to work. So we have actually multiple categories. It would be good to show you a demo of of how it works. So we might start with the we might start with. Can I stop sharing this? I need to share. Okay, just give me a second here. My virtual camera didn't work, so entire screen. Okay, so here I'm sharing the entire screen. I hope that you could see it. And if we move on to the to give you like a quick example of what we have been able to achieve. So we have been able to transfer files, to update the states, and all that. I think that the presentation is too short to explain everything in this project because it's massive, and we have been working on this for quite some time now.
Just to be sure, we still see the slides.
Yeah, could you see what I don't know what you exactly are you seeing? So the
We are
virtual.
seeing the Google Chrome with the slides.
Okay, okay. Could you see the entire screen now?
Yeah, yeah, yeah.
Okay, so this is the offer board, and once again, this has been designed with carbon Kivy, and the designer is no Felsec. He did a great job on the board. And as you can see, we have built everything from scratch. So we don't use Google Auth, we don't use GWT for tokenizer. We use our own things. So let me quickly do this. So this is we created our own MFA, so our own multi-factor authentication. As you could see, we have requested a passcode, and we got a passcode so we could register because the board is much stricter for a login. So we have to control anybody who's trying to log in, and it's bound by IP, it's bound by MAC address, it's bound. So a slight change, like a fly, we would catch that, and everything is logged. So as you can see, this is the board, and if we go to here to like the dashboard, and we could see this. So this is actually a driver. So if I open the driver's application and I tried to log in, so I previously saved my logs. So if I do this and I click on this, you could see that I have a bunch of files. Those are GDPR compliance files. So in England, to operate as a taxi driver or as a private hire driver, you need to have at least one valid card, and you could at least have your profile related documents all valid. And we could and we could adjust those files. Like we could actually go here, like for example, the DVLA. We go inside, maybe select a file like this. Let's try to put any file. For example, we choose to put this. I don't know what file I'm selecting, so we just apply. And whenever the user modifies the file, we have a note here that says that modifying a file will render this document invalid. So an operator go inside the board, and we just refresh, and maybe we could see what the person uploaded. Okay, so you see the picture that I have uploaded, and this is, and also the operator could also validate files. Okay, so if I go back here, as you can see, it's invalidated, but I have validated the file from the board, and I just click refresh. It's all good, and we can operate. So again, what we're gonna do, we're gonna select a card, select a category to operate in. Okay, then just hit this. So this way, we're receiving jobs. Okay, and to make sure that this driver is alive and everything is good and all that. So let me just quickly check one quick thing. So just tell me about the time. I'm not managing the time very good. So if I stay too much on one point, I'm not gonna be able to finish the whole presentation. So if we go to the monitoring here, so we actually pull the log and go to the monitoring, which is 45. Okay, so you could see that we're already fetching the drivers. So if we go to the map here, and we see what we have selected as a category. So we have selected this card. We have Awfer, Awfer X, and Awfer XL. So if we select one category here and we just apply filters, we will see a driver. Okay, this is my actual position. Now we could track like 1,000 driver at the same time. Okay, the tooltip is bugging. I don't want to show you the tooltip now. I didn't have time to fix everything. So, and you can see it's very smooth. And if we select another category, we could see that this guy is active on double categories. We actually have a tooltip. If I have it, it's on the Over project on the Discord channel. So this is what we have done according to relating to the regulatory, um, I don't know, authorities, what the authorities care about. And plus we do have one more thing which is very interesting, which is the log. So operations, I don't know where am I exactly, so not here. Price management. Okay, there's the price management again, and we do have operations and statistics, offer control. This is for promotion codes, so we could actually edit the promotion codes. This is already working. And again, this board has been designed by NoFelSec. It is really cool. It took us from one spot to another spot. This has been developed with Carbon Kivy, and I think it's really cool because the way I designed the board, it was so ugly. Now it looks very perfect. When an investor sees this, it's really attractive. I forgot what I was telling. So let's just go back to the product. So again, this is the offer board, and as you could see, this is what we could do. We could modify the price, like view the logs in real time, view the resources in real time, just ban users. We could do whatever with this board. there's actual endless utilities, and we are actually every day working on this. So each like 3 or 4 days, we just include another socket and add another feature. And there's actually one more thing that I want to show you guys is this. So for the for the price management, now we have spent like 3 or 4 months designing like an equation for this pricing system. So this pricing system to work, it took us like 3 or 4 months to finish just the equation, to implement it another month. So now we do have an instance on GCP. I don't want to run it because I will consume a lot of time just trying to make it work. But this is a test for the pricing where we modify the pricing live. Again, this is on GCP on a real trip. We could impact the pricing of a trip for a customer, for a driver. We could impact the price in day, in night. We could impact the price of a zone. We could impact anything, and however the way we want it. So now, as you can see here, we went to the pricing. Okay, we went to the pricing and we just did. Okay, the video is bugging. This is very bad. This is why I downloaded VLC. So okay, let me just keep it working. So here we selected the category. Okay, for example, Awfer, and then what we did, we went inside and then modified the hourly wage of the driver. So how much we're giving the driver per an hour. Okay. And again, our platform does not like limit the drivers how much they earn or how much they're going to make. It's just they have one restriction, which is made by the law. They could drive with us for I believe 8 hours of drive time. So we changed the hourly wage, and we changed the distance, for example, the distance price, and then we will try to initiate the trip. Now the distance price is set at 2. Okay, we'll place a pin. I wanted to do this live with you guys, but it would take a lot of work and I'm doing a lot of stuff, so I'm really sorry about this. So as you can see here, we ordered the trip, and the distance for Awfer, we increased the distance. It was 1, now it is 2. So the price for Awfer here is 13.98. Okay, so we do this, and then we're gonna try to. Okay, the video freezed again, and I'm really sorry about this. It's VLC stuff. So here we place the pin, and we're still at 2. Okay, now we modify the price. We set it to something like 10. Okay, we just order another trip, and you just place the pin the same place, and the same place as the previous time, and then we could see that the price actually changed. So this is done through pure sockets. So this is not going through HTTP. This is not going through anything. This is pure TCP models that are working in the background, which is really amazing. Okay, and yeah, I think that I'm missing a lot of things to tell you guys. So for example, when we prompt the customer with the drivers, so in here there are a bunch of drivers shown around the customer. So for each category, we're showing like 6 drivers, and this is controlled directly from the board. We could control how many drivers we're going to show to that customer per category. Like we could set it to 3, you could set it to 4, we could set it to 5. Everything is customizable through this board. And yes, so select a category, and that's it. So that's for the pricing. which is very important. And there's one more video that I want to play to you guys, which is the call itself. And again, I'm really sorry about not getting the GCP running for you guys. Let's say I think it's 5:20 where you get to see the juice. So in here we just place a pin and we get the same prompt. No, this is from an older version. As you can see, the prices are not very accurate. Now we were not applying the prices, we were applying like a fixed price. So this video taken from previously, and now we're working on a proper new version. I'm going to show you uh, in the customer app very soon. It doesn't look the same. Now we have like a day, like we have light and we have dark and all that stuff. These ones do not. They are from a very old quilt, like from 5 or 6 months ago. So we just place a pin, we just order, and as you can see, directly the driver gets the call. So we get a timer and all that, and once he accepts, we get a prompt of with what do you want to navigate with Google or with Waze or with whatever you want to navigate with. And as you can see, it's very smooth. So if the driver doesn't accept, we just go to the next driver. And we have worked on the thread events and all that. It was really complicated and a huge amount of work. So it has been 3 years since we've been working on this, and we're getting to a point where we're ready to finish the first proper Android version. So we just go back to the presentation, and we go to coupling our design with Kivy. So how did we do it? So our stack is made of 36 APIs, totaling 64 sockets and 2 HTTP requests. Now those 2 HTTP requests are Dockerized, so we're not dependent on a third party like navigation provider. What do we have is we do have this. So we do have this sudo docker PS. So we do have Nominatim and we do have open root service. We customize this so that we use our own tokens, and we have created like a service that reroutes the tokens. Okay, that takes the HTTP request, split the token, send it to our authentication service. Okay, it gets its authorized answer gets back to Nginx. Then we reroute to the right Docker container. So either we're looking for an address or we're looking for anything. So this is how we're doing things, because we should have talked about this in the presentation. Okay, so just bear with me a second. This is the NVIDIA stuff. So yeah, I should show you just one thing really quickly. I know it's too much time, and I'm really sorry for taking your time. So let me just show you something. So this is the new. This is what we have been reworking. Okay. So this is actually the customer application. So we just log in. There's no Google. There's nothing. So it's just flat login like this with tokens and everything in the back. So for the addresses, we use our own. Like I was saying, we use our own container Nominatim, which we configured, and it's really a pain. So this is my position. Where am I actually right now? And this is when I try to get an address. So this is my postal code where I live. I live in Nigeria. So this is my real address. So when I do this, I get this. And from where do I want to go? Let's say, for example, I want to go from a different place. So this is just for sake of demonstrating how things work. So you get a route. Okay, it's very simple. Okay, there's light, there's dark, and we could also add another star. We have a total of five stops. So we do this, and as you could see, we do have our stops here. So this is the one shows the number of stops. We have five stops in total. This is the real work that we have been working on, and we just go next. So also the route that we were drawing, it uses open routes, our own open routes, our own dockerized open routes. So and big thanks to open routes and big thanks to Nominati making this huge work. It's like they created something, they give it to you so that you could work and use it in your commercial project. And for me, from my point of view, it's no different than Google or anything or Waze or whatever. So now just go to the coupling. So our stack uses, like we said, 36 API for sockets and two HTTP requests. So we had to standardize our requests starting from the initial calls made on the front end to their processing on the server, and finally formalizing a readable, consistent response. This is where things get really, really interesting. So this is what I have tried to create. So on Android, because you have to understand, now we didn't move to iOS. So I have built something that when transitioning to iOS, I would have to only move two services, the chip service and the tracking service, to the iOS. So I don't change the whole application. I just change two services and the application will work on iOS. So I'm dependent on SQLite. SQLite works everywhere in rockets, in embedded systems. It works everywhere, and we are using it everywhere. It's allowing us to update 1,000 driver in 0.001 second. So there is no limit to what you can do with SQLite, and people are taking it for granted. And I thank SQLite for making this project coming coming. Coming to this point. So, coupling our design with Kivy. So, the calls, we have two types of calls. We have the calls that are directly made from the UI, and we have the calls that are made from the foreground, like foreground services. This is what we are using. So, we're using a foreground service to update the state. We are using a foreground service to keep track of the trip, of the actual trip. So if the driver decides to close the application, he should be able to keep updating his status. Whenever we change a category, the category that we change is applied directly to the database on the server in real time. So the updates have happened each 1 second. So Uber is doing it every 5 seconds. This is standard market, but for us, we could do it each second, and we could handle the load. So there is no problem. We are much, 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 much more efficient than any stack that is out there. We are using things that are very close to the system, like sockets and all that. So the Kivy mobile apps or control board depend on two core components: the TCP model that initiates requests and waits for responses, and the DB handler that allows reads and writes of data. That sometimes must be shared between foreground service and the UI. So, for example, when we change the category, we write into it a database. That database is read by a service, and then the service update the latitude and longitude and all that into it, then sends it to the server. So this is what we have. We have a TCP model. The TCP model could write to the DB handler. The DB handler also, the TCP model also could read from ask the DB handler to read a specific database. And the TCP model also is called by the service, and the service could also read the results from the TCP model. And this is the application. So from the application, we send data to the DB handler. We could ask the TCP model to initiate a call, do that. All this is done this way. And on Android, we have a local database, so we could share the data between the service and the actual application. This is our design, and this is what we have created. So I have spent like 2 months trying to create this. So it was like a complete joke at the start, but at the end, it really paid very, very, very well. And we go next to the next one. So this is our TCP model. This is an example. This is an example of how we're doing the actual calls. So the TCP model, for example, if you want to delete or insert a card, the code is garbage, guys. Just don't look at the code. It's like logically, this is what we're doing. So we just make a call. We use threading. And why do we use threading? We use threading because we're calling this from the UI. So this call will take, for example, less than a millisecond, less than half a second. And our all services has our every service has a timeout. Like to better understand, I have to show you something. So that you could understand what I'm trying to say. So, for example, this is our configuration. Again, this has not been moved to the shared memory. The things that are on the shared memory, there is the rate limiter, there is the log, which is on the rate limiter for every party, the drivers, the users, the operators. Everyone has its own rate limiter living in the shared memory. For the config, it's still too long. I cannot just put it there and modify the table of RAM inside. So it's a lot of job to do. So I have to finalize every call, then put all the global config in just one place. So for example, this is for testing. Our socket timeouts are 2 seconds. So each 2 seconds, the connection, the request will die eventually after 2 seconds if you don't get the request. So here's the Awfer TCP model. So we initiate a thread from the UI, which we know that Android is not going to kill because it is going to take like less than a second. So for a thread, it's like 10 seconds. Android will kill it. It cannot live up there. So, and then we initiate the clock to wait for that result. And once we receive that result, we either receive done or OP fail or unauthorized, or we receive our list or we receive our dictionary depending on the data that we have. For example, for this operation, when we delete or insert a card, we expect a done or an OP failed or unauthorized. This has been like generalized over the 34 APIs that we have. And for the DB handler, for example, if we want to update our email, we're just going to use this. So from the UI or from the service. So the DB handler has a bunch of these functions like update email, read something specific in that row. This is what we're using. And Android, I haven't encountered any issue with SQLite and Android. This is the only area where I haven't met any problem. And then again, we go next to what is this? So this is our call. This is what resides in the TCP call itself. Okay. So this is our one call, our example of one call. We just read the token that we received. Okay, the token is stored. So if someone tries to change the device, we detect that he changed the device and he has to do an email authentication. He has to do an email, a multi-factor. Uh, you know what it is called. It's only one time, whatever it is. So he has to prove that it is him who's trying to send this request. So it's bind to the MAC address of the device. So this is how we're formalizing a request. So we do token plus the MAC address plus the request that we want. That is coming from the UI. Okay. And then we wait for we just main socket send, then we decode. If we get a token, we don't get an answer, we renew the token, then make the call again. Okay, and we have we have a delay time, we have a retry time, and all that. And of course, we have error codes for each let's say for each call. Each socket has different has different error codes, so we know exactly where we're tracing. As you could see here, I'm not using like exception as E. I'm not returning the exception, but I am returning these errors. So I could, it's in my opinion, for me, I prefer this. So I know exactly what it is. And this for example, these error codes are just for the driver. There's error codes for the customers, error codes for the operator, and etc. And we honest the wall and the road. I know that you have done a great work with this framework. And to be honest with you, I haven't worked. I have used before OpenCV. I worked with OpenCV a lot. I worked with TK Inter before a lot. But with Kivy, I use Kivy like more than anything else. Okay, I use sockets in Kivy more than anything that I have used before. I don't know much. I know Python, sockets, and Kivy. This is what I know. It's pretty simple. It's like we went to a school, we studied, we got a degree, and then we just started programming, started doing things that we love. But for me, Kivy was like something else. It's like you're doing stuff on Ubuntu or on Linux or on Windows, and you're just switching to Android. At first, you think that Android is just Linux, and then when you switch, I've said this many times in the Discord channel. It's like Android doesn't give you any liberty. You don't have any liberty. It's like you have none. Like there is no liberty. Everything you do, or like if you try to read anything from the user device, you have a permission. Anything you have to do, the slightest thing, you need a permission. And for me, transitioning from Linux and all that foundation, all that studies that I have done, going to Android, it's really confusing, and especially starting from Android like 11 or I believe 12. It's there when we started facing problems. So let me just read this. So at the very start of this journey, we tried to see if pure Python for front-end solution was feasible to compensate for the lack of multi-language knowledge. So we started reversibly doing the hardest functionalities first, like tracking drivers, fetching the fastest driver per category, calling drivers, and all those tasks that seemed exhausting. But here's the reality. But it was harder and much time consuming to keep a thread running with our app than to build a shared memory estimator or getting the server to reach like 110K requests per second. We spent 6 months to make the tracking service works from Android 10 to 14 to just break on the next release of Android 15. It's really exhausting. And eventually, this PR by Kengun, he talked about it in the morning. So this solved our issue. And and to be and I haven't spoken about our team. Obviously, we do have our very honorable man, which is Alauddin Lara. He's a very very good man. He's our COO, and we do have two team members. We have Nofensek, and recently Kengun started working with us. So Kengun made this PR, so where we could make our service working even on Android 15, and he worked on the notification and all that. Because when we have our phone locked and all that, the call, it's like we need to make like a proper call, not just like try to pop up the call from the. Uh, Now, I'm sorry. Let me try to rephrase this perfectly so we're clear. So, what we did have, we had in application when we receive a call, the phone had to be like turned on. It had to be not locked. If it was locked, the call was not going to be received. The call was going to be received after you unlock, after you do that. So we had to implement like a call, so a proper call. Like when the phone is locked, you get the call. And and this is what Kengun has been working on, plus the notification and the service in the foreground. So before Kengun started working with us, we had we had this. This is absolute. It doesn't work on Android 15, so you don't need to worry about this. So, but either way, I'm going to show it to you because we spent so much time doing this. So, so CD driver up. Okay, so we go this. We go. Just give me 1 second. I'm just confused, super confused. Okay, so we go to resources, we go to services, and we have this is our tracker. Okay, this was working like from Android 10 maybe to Android 14. Now I'm using Android 14. It works perfectly. Imagine that I had to just put this line here just for the auto restart. For there is a lot that I do not understand, and especially related to PyGenius and all that. The documentation is not very clear, and I'm sorry to say this. And I wish things were very clear. When I started this project, ChatGPT didn't exist. Like when you asked about PyGenius, it didn't give you like a proper answer. It didn't like you understand. It's very very complicated. So this we have this working until Android 14. Let me try to make it bigger a little bit. So we had this working until Android 14, and then on the release of 15, it stopped working. So well, once again, Kangoo is working on this, and he made a fix and made a PR, and everything is good. So we're just moving forward with a new call and all that. And I think we should wrap this up. So speaking with all this and what we have been saying, so what we have actually achieved, we have to look at this from perspective of numbers. So we have talked to investors before, and we did a round of interviews with investors, and we tried to raise a fund. But we did like 8 or 10 interviews. We posted like an offer on LinkedIn, and we did some interviews. People got really really interested. But when they saw the difference between us and Uber, when they saw that it's like the margins, when you look at it, it looks like a fraud. The difference between us and Uber is very different. And this is even without a softener. Our softener, like when we do the pricing for the when we cite the customer or cite the driver with a pricing, we sometimes have a small equation that is related to we have a small like how do we say, I'm just calling it softener. So when on short distances and like this, the softener adjusts the price. And this is without like adjusting the price. The difference between us and Uber is like 31%, 46%, 29%, 2%, 92%, 20%. It's huge. And our charge to run this, it's not just the platform, it's our operational cost. Our whole operational cost to run this application is 23,820 pounds per month. I have went over this like many many times, and I made the numbers perfect. We have achieved in the most pessimistic scenario, we could achieve like 389 89% in ROI. So and this is very good. If I show you and this is very pessimistic. So where we're starting in zone, which is Bristol, North Somerset, and South Gloucestershire and Bath. There's a total of 6,000 drivers. So this is less than 10% of what the market offers of drivers. We already talked to drivers. We already talked to accountants to help us get in the drivers. The drivers are not the problem, and our system could handle the whole zone without even choking. Like I could handle like maybe London plus Bristol without even the back end shaking at all. So this is very 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 pessimistic, and we have these numbers. On the optimistic, on the optimistic scenario, we have numbers that goes like insanely up. And the more we have drivers, the further we drag the cost down. I didn't want to talk too much about the back end because this is like very much related to like front end, Kivy, all that. So this project this project is made around like the back end. It's not very much of a front end project like it is for a back end project. Yes, we are dependent on Kivy for front end, but our GCP model is pluggable. Our everything is pluggable. It's like we're not very much dependent on anybody. We're like we like to have this approach and this philosophy to drag the prices even lower. So Kiwi is open source and there isn't much noise around it. It's the things that the functionalities that we have are already stable. We're not trying to use like extra things that are not stable and all that. And I'm sorry for consuming all your time and thank you very much. And there's a lot to cover on this project. I didn't have much time to go over all the things that we have done because there is too much that we have done. That's it. Thank you so much, guys. And before we end this, I want to especially thank Alaaddin Laga, he's our COO, and I want to thank Nofran Sek for working on the board. Man, that was a great job. And Ken Gould recently joining us. Well, thank you so much, bro. And I hope that you could contribute much to this project and to the Kiwi core developers. Thank you so much. I want to thank Robert Flatt. I want to thank Cheaterman, and I also thank everybody that helped us on this project in any kind of way. Thank you so much.
Thank you too for
If there's
sharing
any
with
question,
us
I'm
what
to answer
was
that.
your journey with Kivy, your journey with your product. Looks super interesting. Please let me know when you go live with the website and the first demo
Yeah, we
in the
already have
area you said
plans. We
previously.
didn't, we just didn't spoke about it. The website is already running. We have a domain. We have all that. Everything is installed. The GCP is working. The ports are working on GCP. All that is working. So I just needed to configure the email server. That's it, and link it to the GCP. So I don't just have time to speak about everything, and I just didn't want to go out of scope. But since you understand better than me, I had to talk about the things that maybe are not very much related to Kiwi, but they uh, really like it's like they are very close. Like without this front end and without that back end, we cannot achieve this.
Yeah, yeah. So thank you again. And for today, we finished with the Kivy sessions. So we will do another Kivy session, I guess, during the next year.
Thank you so much. Thank you so
Thank
much.
you. Thank you
Bye bye.
everyone for joining us and see you on the Discord chat.